Alright, Kathy, we're going to finish your test review here. We're going to work number 9 here, this weird division problem with this complex fraction. I want you to think about this as 2r to the 4th t squared over 3t divided by, that's what this big long bar means here, that means divided by 5r squared t to the 5th over 3r. So it's very similar to a problem we did earlier, it's just in a different form. And of course you told me that you know when you're dividing that you're going to flip this second fraction over and multiply. So we really turn this into 2r to the 4th t squared over 3t times 3r over 5r squared t to the 5th. So we flip that over and multiply. Now let's see if we can simplify. There is a t squared on top and a t to the 1st on bottom. And there's a t to the 5th on bottom. We've got r's, we've got numbers, and this is what I think I will do. I think I'm going to go ahead and multiply straight across first, and then multiply the denominators together, and then we'll simplify at the end. So in the numerator, we're going to have 6 r to the 5th, because r to the 4th times r is r to the 5th, t squared. And in the denominator, we're going to have 15 r squared t to the 6th. Okay, let's see. 6 over 15 can be reduced. You can divide both of those by 3. So that's a 2 on the top and a 5 on the bottom. Now, when you have like bases like this r to the 5th and r squared, you told me earlier, you're going to subtract those. The bigger number, the bigger exponent of r is in the top. So 5 minus 2 is 3, and we keep it in the top. So that's r cubed. Now here, with our t's, the bigger exponent is in the bottom. So here we're going to have a t to the 4th in the bottom. 6 minus 2 is 4. And that's going to be your simplified answer for number 9. Okay, let's go on to number 10. This is, again, a complex fraction. I'm going to make common denominators in both of them, bring them together, and simplify. This is going to be several steps. So first of all, I'm going to rewrite this as 1 over g minus 1 plus 2 over g plus 2. And then this is all divided by 2 over g plus 2. I don't think I left myself enough room there. I wanted to. Minus 1 over g minus 3. I'm going to go erase some of this and leave myself some more room. So give me just 1 second to do that. Yeah. And plus, I need a little bit more room there. 2 over g plus 2. Okay, so the common denominator here, the least common multiple between g minus 1 and g plus 2 is g minus 1 times g plus 2. So on the top here we need a g plus 2 and make this a g plus 2. And then on this side we need a g minus 1, and here we also need a g minus 1. Okay, so what do we need here? This one needs a g minus 3 over g minus 3. This is messy. And then this one needs a g plus 2 and a g plus 2. Woo, look at all that. Goodness, I'm tired and frightened all that. Let's see what we have. Okay, I'm going to have in the, too far. In this first fraction here, I'm just going to have g plus 2 over g minus 1, g plus 2. And then plus, I'm going to distribute this 2 through there, and that's going to be 2g minus 2 over g plus 2, g minus 1. And that is still all divided by 2g minus 6 over g plus 2, g minus 3, minus g plus 2 all over g minus 3, g plus 2. And I'm going to go ahead and make this a plus, change that sign, and change that sign. Alright, I'm going to bring these together, and then we're going to reciprocate and multiply. Since we have common denominators, on this one I'm going to have g minus 1, g plus 2 in the bottom, and then g plus 2g is 3g, and 2 plus negative 2 is 0. So I don't need to put anything there. Let's see what happens in the bottom. 2g plus negative g is just g, and negative 6 plus negative 2 is negative 8, and that's divided by g plus 2, g minus 3. This is a messy, messy problem. That's a weird looking g, sorry about that. Okay, so now I'm going to take this bottom fraction and flip it over and multiply. So we're going to have 3g over g minus 1, g plus 2, and then times g plus 2, g minus 3, over g minus 8. Okay, so now that we're multiplying, I can cross off those g plus 2's, and that will give me 3g squared minus 9g in the top, and then the bottom I've just got g minus 1 times g minus 8. And I don't know if on your key, Kathy, if he multiplied the 3g times the g minus 3 and left like this, or if he just kept it factored out like there. You might let me know. I'm just curious. But that's what I think the final answer is for that one. Okay, here we're going to start by factoring. And if we have an equal sign, this is not going to be as bad. And you're going to like this better. So I'm going to have b plus 4 over. If you factor this bottom, you're going to get b minus 2, b minus 1. And then the second fraction, you're going to have b minus 3, b minus 1. And then on the other side, we're going to have b minus 3, excuse me, and b minus 2. Anytime you have an equal sign, you have the right to clear your fractions. And what I mean by that is if you find the common denominator or the least common multiple and multiply everything through by that, then you get no more fractions, which is nice. So I think here the least common multiple of the denominators here is b minus 2 and a b minus 1 and a b minus 3. I think from what we talked about earlier, I think that you'll understand that pretty easily. I'm going to multiply everything through by that. So I'm going to multiply every single fraction by that. So this is how that will look. B minus 2, B minus 1, B minus 3 times all of this. B plus 4 over B minus 2 and B minus 1. Also, I'm going to multiply that by the second fraction. I'll show you what happens. And then I'm also going to multiply it by the other side of the equal sign. Okay, so here's how this is going to look. When I multiply this common denominator through by this first fraction, the b minus 2 and the b minus 1's cancel, and I get b minus 3 times b plus 4. Now when you multiply this least common multiple through by the second one, the b minus 3 and the b minus 1's will cancel, and you'll get 5 times b minus 2. And then on the very end, the b minus 3 and the b minus 2's cancel, and you get b minus 4 times b minus 1. So I'm going to multiply all this out and see if we can't solve this. I'm going to have b squared plus b minus 12, and then minus 5b plus 10 equals b squared minus 5b plus 4. And I'm going to get everything together on one side, or actually I think I can solve this easier if I collect like terms first. But if you do a b squared on this side and a b squared on that side, that cancels. And this minus 5b will cancel with this minus 5b on the other side as well. And so I've got b minus 12 plus 10 is b minus 2 equals 4, so b equals 6. And again, let me know if I got that right, because you have the key there, but that looks good to me. You could go back in and plug in 6 and make sure it worked out, but I want to keep the video sort of shorter. So let me know if we got that right. Alright, and then the last one, we want to solve this for z. So we've got 9x over 1 plus 3 over z equals 5 over y. I'm going to do the same thing here. I'm going to multiply through, because I've got an equal sign, by the least common multiple. And that least common multiple is, that's a weird z, sorry about that. The least common multiple is zy. So I'm going to multiply everything through by zy. So on the top, it's going to give me 9xyz. That's sort of funny. In the second fraction here, the z's cancel and you get 3y. And then on the other side of the equal sign, the y's cancel and you get 5z. So to solve for z, that means we're going to get z on one side by itself and everything else on the other side. So I'm going to subtract 5z from both sides, bring this 5z on this side, and then I'm going to subtract 3y from both sides as well. I brought everything together that had a z in it on one side, and then I'm going to factor that z out. And then I'm just going to divide through, and I will get that z equals negative 3y over 9xy minus 5, which, by the way, I don't know how your answer key looks, but that's the same thing as positive 3y over 5 minus 9xy. So I don't know what version he has it in. Either one of these work. But anyway, if you just send me a text or a message and tell me if we got these right. But that's what I think the answers to those other questions are. So I will talk to you later. Bye.